So hello everyone, welcome to IBDP MAA SLHL course, and in this session I am going to cover number algebra subtopic 1.6, in which we will see how to prove left hand side is equal to right hand side, what's the meaning of equality and identities, right? So I will discuss everything in detail. Sometimes students find difficulty in understanding what this means, how to simplify these type of questions and what we have to do and what are the types of different questions that may be asked in the exam. So in this video, you will get answer to all those questions. Okay. So let's get started with the names of the subtopics first. So the thing is, we have simple deductive proofs, numerical and algebraic, where we have to either take left hand side or right hand side and make it equal to the other side. Okay. Also, we will discuss the symbol and its meaning for the equality as well as identity. Equality you are already familiar with. Identity is this, which is true for all values of that variable actually. Okay. So let's get started with the first question. This is the product of three consecutive integers is increased by the middle integer. Then prove that the result is a perfect cube. So we have to prove something, right? What we have here? We have three consecutive integers. What that means? It means we have three numbers, say, let's call them x. Second number is x plus 1 and the next number is going to be x plus 2, right? This is the general form for three consecutive integers. Now their product we have to take. What is the product of these three numbers? Let's call it P. Product is x times x plus 1 times x plus 2. This is the product. Now we have to increase this product by the middle integer. So in this product P, we have to add the middle number. What is that? X plus 1. Now this is my expression and I have to show that this P function is a perfect cube, right? We have to show it is a perfect cube. It means you can write it as something whole raised to the power 3, right? So in order to show this, let's factor out something which is common in both of these terms, right? Here we have two terms. One is this and the second one is simple x plus 1. So yes, we do have x plus 1 common in both of these. So take out x plus 1 common from both and we are left with, from the first bracket we have x times x plus 2 and from the second bracket we simply have 1 only, right? So this part is already in the simplified form, so just leave it x plus 1. But for this part inside the bracket, we have x times x plus 2 plus 1. There is no common factor, but we can simplify it further. So this x gets multiplied with x as well as with the 2. Let's simplify it. We got x squared plus 2x and this plus 1 as it is. Okay. Now, do you know what is that? X squared plus 2x plus 1? Yes, it is the perfect square of x plus 1, right? So this portion over here is the x plus 1 whole raised to the power 2, because you can use the identity a plus b whole squared. A squared plus b squared plus 2ab. It is here. What is we got? We got x plus 1 whole raised to the power 3. Or you can also factorize it if you don't know how to write it in this form. From this step, what you can do is you can take x plus 1 as it is and factorize that portion inside the bracket. So what is that? We have x squared plus x plus x plus 1 by using the middle term splitting method. So I'm just rewriting this 2x as x plus x. Okay, I'm using second method. Here I used one identity and here I'm using the factorization. So x plus 1 as it is. Now factorize this quadratic into linear factors. So take out x common from the first two terms. So we got x times x plus 1 and these stays as it is. So plus x plus 1. Okay. Now again leave this x plus 1 as it is. From this we can factor out x plus 1. Okay. So x plus 1 common, and once you take x plus 1 common, you will get x plus 1 in the bracket again. So what is that? Again it is x plus 1 whole cube, which gives you the same result. Hence proved that it is always going to be a perfect cube. So I just took the general example, right? I'm not taking any numerical values directly. I just took x, x plus 1 and x plus 2 as my three consecutive integers, and using that in general I showed that if the product is increased by the middle integer, it is going to be a perfect cube. Okay, let's take one more question. Next one says we have to show that this 1 over m minus 1 plus 1 over m plus 1 is equal to this 2 over m squared minus 1. So I have to show that this left hand side when simplified will give you the same thing. Okay, so that is identity, means both sides are same thing. So now take the left hand side. Left hand side says 1 over m minus 1 plus 1 over m plus 1. What do you think is the next step? Taking the LCM. So let's take the LCM of these linear polynomials. We will get m times m minus 1 times m plus 1. Then this goes to there multiplied by 1 m plus 1. And on this side 1 times m minus 1. This is what we got. Okay. Now simplify it further. So in the top, what we have? M plus 1 plus m minus 1. Simplify it. We will get 2m divided by m plus 1 times m minus 1. Now using the identity of a plus b times a minus b, we got 2m over m squared minus 1, right? A plus, here I am using the identity a plus b times a minus b is equal to a squared minus b squared. Okay, so hence we got our answer. Hence the proof. Okay, now next part. If x equals, remember, if x is equal to ax plus b, then we have to find the x in terms of a and b. We don't have to solve for a and b. We have to find x in terms of a and b. So take all those terms which have x in it to the one side. So I can rewrite the same expression as x minus ax plus or equals to b. Now take out x common, x factored out. So we got 1 minus a equals to b. Now we got the value of x. What is x? X equals to b over 1 minus a. This is our answer only. Okay. So here we got our x value in terms of a and b, which is our final answer. But in the b part it says x, this time you can see identity is there. Ax plus b for all values of x. We don't have to find x in this case. We have to find the values of a and b in this case, where this is true for all values of x. Right? So if it is true for all value of x, what that means? It means both left hand side and right hand side must be same thing. Right? So I have x same as ax plus b. So I can compare the coefficient. Compare coefficient of x and constant term, because it is identity. That's the difference between equality and identity. Okay. So what is the coefficient of x on the left side? X. It is 1 only. Right? So I can say 1 must be equal to coefficient of x on the right side, a. So value of a is 1. Similarly, what is the constant term in the left side? There is no constant term in the left side, so I will write 0. So I have actually 0 plus 1x. So on the right side, what is the constant term? Means without x, b. So it means 0 must be equal to b. Hence we got the values of a and b in this way. Okay. So I hope you got this. In the first part, we solved for the values of a, x in terms of a and b. And in the second part, right, we found the values of a and b where this identity holds true for all values of x. Okay. Next problem. It says show that 2n minus 1 whole cube plus 2n plus 1 whole cube equals 16n cube plus 12n for all n integral values. Okay, so here what you can do is you can use the binomial theorem for it. You can use the identities. You can use the identity of a plus b whole cube. Okay, or you can use binomial theorem to solve this. Okay, in both the ways you will get same answer obviously, right? Now, I am going to use the identities. What is the a plus b whole cube identity? It says a plus b whole cube is a cube plus b cube plus 3a squared b plus 3a b squared. You will get the same thing from the binomial theorem also. And if there is a negative sign, means we have a minus b whole cube. As you can see in the first factor, we have minus sign. So there is no problem. In place of b, just replace it with minus b. So what I am saying is, for a minus b whole cube, we will get a cube, then plus of minus b cube gives minus b cube, then plus 3a minus b square gives plus b square, then 3a square times minus b gives minus 3a squared b. Okay, so this is the result. Let's use these identities for here we have 2n minus 1 whole cube and we are adding 2n plus 1 whole cube to it. Okay, so we got 2n whole cube a cube plus here what we have minus 1 whole cube. So I'll write it minus directly. So minus 1 cube. A cube minus b cube then plus 3 times 2n times minus 1 squared, which is 1 simply. Then minus of 3 times, let's take the, okay, I can take square in the next one. So I got 3 times 2n whole square times minus 1. This is corresponding to the first factor. Now, corresponding to the second term, means this 2n plus 1 whole cube. We have 2n whole cube plus 1 cube, which is 1 simply, plus 3 times 2n or 2n squared, that's fine. Here we have 3 times 2n squared. Okay, now we just have to simplify. So if you observe carefully, minus 1 cube and this term minus 3 times 2n squared gets cancelled with this. And we are left with this one, which is nothing but 8n cube and it is 6n. Here it is 6n and same thing 8n cube, so plus 8n cube plus 6n, and if I simplify it further I will get 16n cube plus 12n, hence proved. Okay, we proved it. Okay, that's the answer. Next part says hence or otherwise, means either you can use the same result or you can start from the scratch. Hence or otherwise prove that the sum of cubes of any two consecutive odd integers is divisible by 4. Actually, the question that we started with means this 2n minus 1 and 2n plus 1. What is that? 2n minus 1 is an odd number. Always, right? 2n minus 1 is the odd number and 2n times plus 1 is the next odd number. Right? So I can say my two consecutive odd integers can always be in the form consecutive odd integers are always in this form of 2n minus 1 and 2n, next number will be 2n minus 1 plus 2, which becomes 2n plus 1 later. Now according to question, we have to take the sum of the cubes. So first we need to take the cube and then we will take the sum. So sum of the cube. I am taking cubes. Sum. So this is sum of cube. What is that? We already know this from the previous part. It is nothing but 16 n cube plus 12 n. Okay. Now I have to show that this thing is always divisible by 4. For that, what you can do, you can take out 4 common from this, right? 4 can be taken out common from this. So you can take out 4, even you can take out 4n as well. But okay, 4n times 4n squared plus 3. We don't need this second part. Okay, this is something integer. We know if n, it is already given in the question, n is an integer. So if n is integer, then 4n square plus 3 is integer, and times 4n square plus 3 is also integer. So this whole thing inside this whole thing must be an integer, right? So what we are getting? We are getting sum of cubes of two consecutive sum of cubes of two consecutive odd integers as 4 times some integer. That shows it is always divisible by 4. Hence the proof. So it is something 4 times k, where k belongs to integer. Answer. Okay. So in this session, I covered all the topics required for this proof equality and identity subtopic, where we started with showing that left hand side and right hand side are equal or not, and the meaning of that identity symbol, right, and equality also. So that is it for this session. I hope you get this all, and if you still have anything to ask, feel free to connect with me. You can book your free demo using this WhatsApp number over here for one-to-one or group session. Thank you for watching this. See you in the next part. Keep watching, keep learning.